So once again, I'd like you to pause the video here and have a go at drawing the diagram for yourself before we put it up on the screen. Okay, so I'm just going to scroll across to the other side and grab our diagram. So a suitcase with a mass of 12 kilograms is maintained in equilibrium. So that means that it's not moving and all of the forces that are going in the same directions are going to be equal to 0. So it's on a smooth plane inclined at 60, which means this angle in here is 60 degrees. Calculate the tension on the strap and the reaction of the plane if the strap is parallel to and acting up the line of greatest slope. So that means that we're going to be looking for this tension line here. I hope you swallow that whistle. Okay, so if you look at our diagram over here, if that is the angle that we have, that makes that the opposite side. And this will be the adjacent side. So that's why we've got cos theta here and sine theta there, opposed to what we're used to. Now, the other thing that we're going to be looking at is the direction of the forces. So the normal force is the force pushing up out of the box, and its resultant force is pushing down from the box, which is they're acting in opposite directions. So normally, to find the force, we would do the forces, add them, and let it equal to 0. So F1 plus F2 equals 0. Now, in this case here, my force going up is N, plus the force going in the opposite direction is 12G cos 60. Now, it's going in the negative direction, which is why instead of being a positive, it's going to be a negative. So that's going to give me that N is equal to 12G cos 60. We can simplify this further using our exact values. So cos of 60 degrees is a half. So a half times 12G will give me 6G for our normal reaction. Now when we're looking for the tension in the string, we're looking at this one here and its resultant force, which will be this one down here. So we're going to do the same thing again. T plus the other force, which is 12 sine 60 is going to be equal to 0, and our force is in the opposite direction, which is why it's going to be minus. So now I've got that T equals 12 sine 60, and I'll simplify this further by changing sine 60 to its exact value of root 3 on 2. Cancel them. That leaves me with 6 root 3. So that means our normal resultant force is 6 lots of gravity, and our tension on the strap is 6 root 3 newtons.